Hello, everyone. Today is actually the last day of Unit 3, and we're going to be talking about the remainder theorem, or the remainder and the factor theorem. So as always, you guys know the drill. Pause your video now, and I would love it if you would try that ignite at the top of the page. All right, guys, final answer for this one, a little bit different, not necessarily a review of yesterday, but it says the figure shown, this is a good SAT question that I pulled off of a previous year's SAT. And it says the figure shows the complete graph of the function f in the xy plane. So it says the function g isn't shown, but it's defined by f of x plus 6. And it says, what is the maximum value of g? Well, you don't necessarily know what g is because it's not graphed, right? But you do know f of x. So simply just knowing that if I look at f of x, the maximum value on that is 2. If I pick any of the highest points on here, the maximum value is just saying, well, what's the highest y value that we get to? So if the max on f of x is 2, then it says define the max value for g of x. It says take whatever f of x is and add 6 to it. So if the maximum value is 2, we would add 6. Final answer on that would be 8. Now, when it comes to SAT type style of questions, especially on the non-calc portion, as a review, you always want to fill in the leftmost box first and make sure that you actually bubble in the number below it. All right. But today, obviously, we're getting into kind of the last two main theorems for the unit. And I think you guys are going to like today because most of today, it's not necessarily something that you have to factor without help. So, because we can use what's the factor theorem in order to help us factor things, polynomials that are a little bit larger. So what the factor theorem says, basically, it says if you have an expression x minus a, and it says if the expression x minus a is a factor of the polynomial, if it is one, if and only if a is a 0 of the polynomial. So basically, if we look at this, helps to look at an actual example. It tells me that given the polynomial and one of its factors, find the remaining factors of the polynomial. So simply because of it tells me that this guy right here is definitely a factor. Now, it's kind of hard to break this down. Could you use factor by grouping and go that route? If that works, yes. But sometimes factor by grouping doesn't always necessarily work based on what the original polynomial is. So what we're going to do is we're going to use the fact that I know that this piece right here is a solution. And what we can do then is we're going to use synthetic division. Let's divide it out and let's see what we're left with. So if x minus 5, to figure out what goes in, to figure out what to use for synthetic division, we set it equal to 0 and solve. So we're saying 5 is the 0 here. So if I know 5 is a factor, well, let's fill it in and let's divide and see what we're left over with. So obviously, I'm going to check for fillers. So I have an x cubed, x squared, x number. Those are all in order, so we are good to go. So I'm going to pull all of those numbers out. Signs and all. And let's begin synthetically dividing. So obviously 1 times 5 ends up being 5. And then we add down, which -7 plus 5 ends up being a -2. And then we repeat. 5 times -2 ends up being -10. 7 plus -10 ends up being -3. And 5 times -3 ends up being -15. Add down, we get 0. And this should happen. If you know something's a factor, when you divide it out, the remainder should be 0. Same concept, if I told you 15 was the number, and I told you 3 was a factor, when you do 15 divided by 3, that makes sense. You get 5. If something is a factor, when you divide by it, you should get 0 for that piece. Now, we're not done though, because it says find all of the remaining factors. So as part of my final answer, I already kind of know what one of my factors is. They gave that one to me. But let's look and see what's left over. we are going to have, now we're going to reduce the power by 1. So it's going to be a 1x squared minus 2x minus 3. Is this now a polynomial that we can now factor? Yeah, of course it is. What times what gives me x squared? We're going to use our handy dandy trusty guess and check method. Now for the what goes in the second part of this, we're going to say, okay, well, what multiplies to give me the last term? Oopsies. What multiplies to give me the last term that adds to give me the middle term? Well, we're in luck because 3, there's only one factor, 2 factors of 3, and that is 1 in itself. And in order to, when I add these guys together, the only way that I can get a -2 from that is to make the 3 negative. So, and I don't know why I put a squared there. Sorry, guys. But x times x gives me x squared, and plus 1 minus 3. You have now fully factored this. Bring those guys down, and you have all 3 factors. All right. So what I want you guys to do, just for fun, I want you to try one on your own. So pause your video now, and I want you guys to try example 2. Okay, final answer is up. Now, obviously for this one, we know that it says, we know that x minus 2 is a factor. So if I solve that, the 2 is the part that goes in for synthetic division. So if I know that x minus 2 is a factor, then let's divide it out. I'm going to pull out all of the coefficients of my polynomial. We would check to see if I need any fillers. We don't, because I go in order. I'm an x cubed, x squared, x number. All of that is golden. So we perform basically synthetic division. So we bring down the first two. 2 times 1 is 2. Add down to get -5. Then -5 times 2 ends up being -10. Add down, we get -6. -6 times 2 ends up being -12. And if I add down, this is the part that should happen. If you don't get 0 there, that means you perform synthetic division incorrectly, because anything that is a factor should produce a remainder of 0 when you divide it out. Now, whatever's left, then we look at this piece right here. Now remember, we look at the cubed. This x is reduced by 1 variable. So if you started with an x squared polynomial, this would be an x, or if I started with an x cubed, this becomes an x squared. If it was an x to the 4th, this would have been an x cubed, so on and so forth. All right, but really the last step, it was just a matter of going through and finishing factoring. So what multiplies to get me -6, that adds to get me -5. The only options are going to be a 1 and a -6. So final factored form is this guy right here. All right. Now, the cool thing about the factor theorem is that we can use this actually a lot of different ways. You can actually use it to find a missing number in a given polynomial. It says, like, for example, for number 3, it says, find the missing constant k so that the remainder is 3. So here's the really cool part about this. If I want to know that, if I know, for example, that the remainder is 3, well, even though I'm missing numbers in my polynomial, that doesn't mean we can't use synthetic division to kind of get us part of the way. So I'm still going to use the same exact concept. I'm going to set this equal to 0. I'm going to add 4 to both sides. Whoopsies. And that's the number that's going to go in for my synthetic division. Now I'm going to check for fillers. So I have an x cubed, x squared, x number. All of those are good. So I'm going to pull out all of my coefficients. And you reach k, you're like, what do I do with this guy? Just bring it down. And let's start doing synthetic division. It says bring down the 1. 4 times 1 is 4. Add down to get 8. 8 times 4 is going to end up being 32. Which, when I add 1 to that, add down, we get 33. And 4 times 33 ends up being 132. So k plus 132, I don't actually know what that is. So I'm going to bring all of that down. And this is where we can use the fact that I don't know what k is, but I do know what the remainder is supposed to be. This guy, remember, whatever's on the end here, this all represents my remainder. So if I know I have k plus 132, I know my remainder is supposed to be 3. And we can use that and let's solve for k. Let's subtract 132 over to the other side. And k is going to end up being negative 129. Ooh, okay. So what I want you guys to do, pause your video now, and I want you guys to give number 4 a shot. All right, so for this one, obviously, we start by finding out what goes in the upper left-hand corner. So for this, that whatever goes up there is whatever the 0 is for this one. So for this one, obviously, x plus 1, set it equal to 0. We get negative 1, so that's what goes in the upper left corner. And then we check for fillers. We say, all right, I have an x cubed, an x squared, an x, a 1. All of that is in order, so we are good to go. So we're going to pull out all of those coefficients, including k. So if k is negative, then technically k is just a number. So negative k is the number that's in front of x in this problem. So that does come down when I start my synthetic division. And I know it looks kind of odd because when we start going through synthetic division, obviously, we start by doing obviously 1 times negative 1, we get negative 1. Add down, we get 3. 3 times negative 1 ends up being negative 3. And as weird as all of that looks, we still add down. We would do negative k plus negative 3 or negative k minus 3. You just can't simplify it. But that's okay. I'm going to leave it as negative k minus 3. And we still take this guy and multiply it by negative 1, which we just have to make sure we multiply both things by negative 1. So negative k times negative 1 is k. Negative 1 times negative 3 ends up being positive 3. And then we still add down. K plus 3 plus 1. I'm going to add the 1 and the 3 together to get 4. So for this one, it says whatever your remainder is. Technically, remember, the remainder is anything that's left at the end. So whatever k plus 4 is, that is our remainder. And we want the remainder to be 0. So that's why I set it equal to 0. We solve, and we get our final answer of k equals negative 4. All right. So factor theorem comes in really handy when we do this. It also comes in handy for other reasons. So if our goal is to find the zeros of a polynomial, factoring isn't necessarily the only way about solving. Now, you're probably looking at this and it's kind of vague. It says find all the zeros. So when we start by looking at this, you might not necessarily know by looking at it what the zeros are going to be. But we actually have a really handy tool of something that can help us here. We have a graphing calculator. If we can use our graphing calculator to find at least one of the zeros, then we can use synthetic division to at least divide it out into something that's usually more manageable for us to solve. So that's actually what I'm going to do. I'm going to get my graphing calculator out. And this is something that I am going to start by graphing. So I'm going to clear out whatever one is there, and we're going to take things in. So it's obviously going to be x to the third, what is it, plus 5x squared. And then it's going to be, let's see, plus 4x, and then plus 20. All right. So let's graph this and see if we can see where any of our zeros are. Not the clearest picture in the world, but I am suspicious that if I look, it looks like it crosses at -5 right in here. So let's check my table. Let's just double check. Let's just make sure that that actually is a 0. And it is. If I look at -5, 0, what you just found is one of your factors because that's one of your zeros. Those are one and the same thing. So if I go back to the notes packet, that means for us, that just tells me, oopsie, sorry, that x minus 5 is a factor here. So if my goal is to find all the zeros, technically you found all of them. You found one of them right now. I know one of my answers is going to be x equals -5. Now, it says find all the zeros though. And that's the only one that I saw on the graph. That's the only place that I see that it crosses. So let's use that to our advantage. At least divide that out and see what we're left over with. So obviously I'm going to kind of go the opposite of what's inside. And I'm going to check for fillers. I don't need any, so it's going to be a 1, a 5, a 4, and a 20. Because we go x cubed, x squared, x, number, everything's in order. And that's my clear to kind of go through and start my synthetic division. So 5 times 1 is 5, and then we add down. 5 times 10 is going to end up being 50. Oh, I'm sorry. Whoosh. It said x equals -5, right? Yeah, it did. Oh, my bad. Miss already messed up. X does equal -5, so I'm sorry. That's the number that's going to go in here. I wrote down +5. That's because technically x plus 5 is going to be what the 0 was, and we would solve and we would get the -5. So 1 times -5 is going to end up being -5, which is going to make this a 0. -5 times 0 is going to end up being 0. 4 times, if I add down, 4 plus 0 is going to end up being 4. And 4 times -5 is going to be -20. Add down, we get 0. Remember, if you know something's supposed to be a factor, your remainder should be 0 on this one. So let's see what we're left over with. Basically, I'm going to decrease my degree by 1. So now it's going to be a 1x squared plus 0x plus 4. And now this isn't something that actually factors. Usually once you get to this step, if you reach a polynomial where either you don't know if it factors, or let's say you can't find it, you don't know, you can't find factors that actually work for this, remember you do have other options. You could use quadratic formula. In this case, this one's a little bit easier in the sense that since I only have an x squared, I'm just going to get the x squared alone. I'm going to subtract 4 to the other side, and then I'm going to square root both sides. It's a little weird, but remember, as soon as we square root, it's going to be plus or minus whatever the square root of -4 is. Now, because we have a negative under the square root, that means I is definitely going to be part of this. And I'm also going to simplify square root of a 4 ends up being 2. So, and this is where it kind of comes into play when it comes to when we deal with different polynomials. However many, whatever the degree is, that's the number of solutions that you should have at the end of the day. So like number 6, the one that we're going to do in just a little bit next, because we have a degree of x to the 4th, that means you should have 4 solutions to number 6. Now, does it mean they're all real? No, not at all. Like for this one, we actually only had 1 solution that was real, and the other 2 were imaginary. Now that's kind of something that's a kind of a neat trick. Imaginary numbers have only come in pairs of 2 because there's always going to be a positive answer and there's always going to be a negative answer. So like for example, this one, since my degree was x cubed, there was only certain combinations of answers that we could have had. You could have had 3 real solutions. You could not have had 2 real and 1 imaginary, because you can't have, imaginary numbers always come in pairs. So you can't have 2 real, 1 imaginary, but we could have had 1 real and 2 imaginary. That's definitely a combination. And because it's an x cubed, that means we can't have 3 imaginary. You can't have odd numbers of imaginary solutions, as another way of thinking about it. So for this one, that just means we have 1 real and we have 2 imaginary. Now the possibilities for this one, we actually have a lot of possibilities. We could have 4 real solutions. We can't have 3 real and 1 unreal, because again, you can't have odd numbers of unreal. But we could have 2 real and we could have 2 imaginary. That's definitely a possibility. Or the last option is we could have all 4 are imaginary. Now that's not always the most common. Is it possible? Sure. We just have to check. Ooh, sorry guys. So let's double check. Let's start by going through. Now again, the trickiest part is looking at this and being like, Miss Hardy, we don't have any zeros. But that's okay. That's what we're going to use our handy dandy trusty calculator for. So I'm going to go to my calculator, and we are going to start by typing in our function. So for us, it's going to be, I'm going to clear this guy out. Oopsies. And I'm going to start typing it in. So we're going to have x to the 4th. Oopsies. we're going to have x to the fourth, and then it's going to be minus 18x squared. Oopsies. Minus 18x squared. And then it's going to be plus 12x. Computer is not cooperating. Plus 12x, there we go. And then last but not least, it's going to be plus 80. Okay? So x to the fourth minus 18x squared plus 12x plus 80. And let's go through and graph it, and let's see if we can see any zeros. Now, just based on this graph, I'm suspicious because I crossed twice, but I don't see two other solutions based on this graph. So what that's telling me right now, even before I start figuring out what all my zeros are, is that I'm suspicious that two of them are real and two of them are unreal. So it looks like they're crossing at -2 and -4. Let's just double check that that's actually the case in my calculator. And it is. -4 and -2 are going to be two of my solutions. So what that tells me is that those are two values that we're going to perform synthetic division with. Come on. And the cool thing is it doesn't matter which one you start with. But this one, the one thing I will say be really careful of is that I'm going to start with just -4 just because. You could start with -2. It honestly doesn't matter. But the key is that we need a filler on this one. Because we go from an x to the fourth, I skip x cubed, and we go directly to an x squared. So for this one, before I actually start writing out my synthetic division, technically we're going to want to make sure that we have a 0 in there in place of the cube term. Because you can't perform synthetic division with missing things. So I'm going to pull out all my coefficients, including the 0. And we're going to perform synthetic division. Bring down the first number. You guys are going to become pros at this by the end of the day. And actually what I want you guys to do right now, I want you guys to do synthetic division twice. I want you guys to at least do the synthetic division part with -4 first. And then whatever you get from this step, I want you to do it with -2. So pause your video now, and I want you guys to give those a shot. All right, if you perform synthetic division twice, the final polynomial of what you should have gotten was x squared minus 6x plus 10. So when you do that, remember, you should make sure you have a remainder of 0 for both of those synthetic divisions because both of them are actually zeros. These are actually 2 of my 4 solutions. Now, I know that this is where I can now confirm that my other 2 are going to be probably going to be imaginary, because there aren't any numbers that multiply to give me 10 that add to give me -6. Now, how to find those imaginary numbers? Well, we learned something last unit. We're going to use quadratic formula. All right. So quadratic formula, if you forgot what it is, it's going to be x equals -b plus or minus the square root of b squared minus 4ac, all divided by 2a. So remember, with quadratic formula, my a is always the number that's in front of x squared, so a is going to be 1. B is the number in front of x, so -6. And c is going to end up being 10. So let's plug in some of those values and let's simplify. So obviously b is going to be -6. So the first thing that goes in here is the opposite of b, which is going to be 6. And then I'll plug it in. B squared, I'm going to take -6 and square it. And it's going to be -4 times a times c. A is obviously 1, and b is going to be 10. All divided by 2 times a, which for us is 1. All right. And really now it's just a matter of simplifying things. So if I'm going to simplify everything that's on the inside, and the denominator, 2 times 1 is 2. If I take this, it's going to be 36 minus 40, which is really going to end up being -4. And now here's where I can definitely confirm that I have my imaginary numbers, because we have a negative underneath the square root. Doesn't mean it's not a solution. It just means that we have to pull the negative out as an I, and then we have to finish simplifying. So square root of 4, that actually turns out to be pretty nice. that ends up being 2. And then both of those numbers, 6 divided by 2, 2 divides by 2. So that's exactly what we're going to do. 6 divided by 2 is going to end up being 3. And 2 divided by 2 ends up being a 1i. And there are your last two solutions. 3 plus I, 3 minus I. All right. So when I say find all the solutions, my hint is whatever degree it is, that's the number of solutions that you should see in your polynomial. All right, guys. The last numbers that you're going to see, obviously, these are the kind of fun ones. These are ones where you're going to use a lot of that information to go backwards and write your own polynomial. So for number 4, it says, write a polynomial of function f of at least degree that has rational coefficients and a leading coefficient of 1 and the given zeros of -1, 2, and 4. So one thing that I know for a fact is if it has zeros of -1, 2, and 4, I already know what part of my polynomial is right now. I know that if -1 is a 0, that means x plus 1 had to be a factor. Basically, we're working backwards. If -1 was the 0, then x plus 1 had to be the factor. If 2 is the 0, that means x minus 2 had to be a factor. And if 4 was a 0, that means x minus 4 was a factor. Now it says it has a leading coefficient of 1, which means obviously a 1 is going to go in front. And we are done for the day. All right. So guys, if you want to pause your video, if you want to check your answer for number 5, I want you guys to give number 5 a shot. Final answer for number 5, you should have got, now do you have to write the 1? Not at all. Sometimes I do just because. But technically you had to have the x plus 3 in parentheses, the x minus 1, and the x minus 5. All right, guys. So you can, if you would like to give some of the You Try Nows a go, you are more than welcome to if you go to the next page. We're going to do some of these together, obviously. But if you're feeling really good and really comfy, then you can move and start working on the homework for today. All right. Good luck, guys, and let me know if you have any questions.